Good morning, everyone. Today, we are going to discuss a few more problems related to inverse Z transform. We will see whatever the problems that we discussed in the previous class and what we are going to discuss in today's class. It is entirely different. So, I'll tell you how it is entirely different. And let me start with the first problem of today's class with find the inverse Z transform. Find the inverse Z transform. Find the inverse Z transform of x of plus 1 divided by Z minus 1 the whole square, okay, into Z minus 1 by 2. So you have to find out the inverse Z transform for the given x of Z polynomial that is expressed in terms of the fraction where region of convergence it is mod Z greater than 1. Okay, so the ROC is mod Z greater than 1. Okay, so the stepwise solution how we have or how we approach is x of Z divided by Z, that would be equal to Z plus 1 divided by Z minus 1 the I need to express this term over here in terms of the partial fraction. Okay, so I need to express in terms of the partial fraction method. So now it is quite simple for you to express it in terms of the partial fraction method. So we all know that how can I express this in partial fraction method, but one thing you have to see that we have a repeated root here. Okay, so this problem is entirely based on the repetitive roots or repeated roots which are there acting at the poles. For example, if I want to plot it over the Z plane, I have real part of the that is the complex number and the imaginary part here, and I'll be having one root at 1 by 2 and the other root at 1 and one more root which is there at this point. So the Z equals 1, Z equals 1 by 2. So I'll be having one more root here. Okay, so this is where the entire picture lays, and you are going to have a circle like this. Okay, so mod Z would be greater than 1. You will be having the positive time sequence, positive time exponential sequence here. So this would be the entire Z plane if I want to analyze it, and this is the ROC. So ROC would be mod Z greater than 1. So this is moving towards the right. Okay, so towards right. Okay, so now let me proceed ahead with the solution part of the partial fraction method where you'll be having x of Z by Z, that would be equal to Z plus 1 divided by Z minus 1 the whole square into Z minus 1 by 2. Okay, so I have A divided by, I'll start with Z minus 1 first root, and again with B. Okay, so I have A divided by, I'll start with Z minus 1 first root, and again with B, Z minus 1 the whole squared, Z minus 1 the whole squared. I repeat, you start with the first one as Z minus 1 and next one with Z minus 1 the whole squared plus C divided by Z minus 1 by 2. Okay, so Z minus 1 into Z minus 1 the whole square, and here I'll be having Z minus 1 by 2. Okay, so now I have Z plus 1, that would be equal to A into Z minus 1, okay, into Z minus 1 by 1, sorry, Z minus 1 by 2 plus C into Z minus 1 the whole square. Okay, so this is A, this is B, and this is C here, and this one is the LHS. Okay, LHS. It is quite simple that, so this equation here, so I'll represent it by star mark. I'll be multiplying with Z minus 1 the whole squared into Z minus 1 by 2, taking the LCM. Okay, taking LCM. Okay, so it is quite simple. If I take the LCM, it is Z minus 1 the whole squared. If I multiply it to A, B, and C, what would be left out? So it is Z minus 1 by 2 here. This is C into Z minus 1 the whole squared, and this one is Z minus 1 into Z minus 1 by 2. Okay, so now it is quite clear for you to understand how we are going to find out what is the constants B and C. Okay, it is quite clear for everyone to find out the constants B and C, isn't it? So to find constants to find constants B and C. To find constants B and C. So to find constants B and C, I need to take Z minus 1 the whole squared. Z minus 1 to be equal to 0 there, right? So B would be equal to Z plus 1 divided by Z minus 1 by 2. Okay, let me erase this in just a moment. Yes. So I have Z plus 1 divided by Z minus 1 by 2. What I'll do, Z would be equal to 1 here. Okay. So now what is the coefficient that is equal to B there? So you have Z equals 1. Okay. So 1 plus 1, that is 2 on the numerator. So 1 minus 1 by 2, that is 1 by 2 again. So that would be equal to 4. So B will be equal to 4 here. So value of B will be equal to 4. So next, what do? I need to find out C. So to find out C, I gain Z plus 1 divided by, to find C, what I need to do? I need to have Z equals 1 by 2 given there. So I will be writing it as Z minus 1 the whole square. So Z will be equal to 1 by 2. So these two terms have to be equal to 0 here. A and B to be equal to 0, it has to be 0 there, right? I mean, this entire term, if I make it 0, then only I'll be able to find out C, isn't it? So this entire term has to be 0 and this one has to be 0 to find the value of C. Similarly for B, you know how to do it. So this is how I can find out the value of C, which will be equal to Z plus 1 divided by Z minus 1 the whole square. And the value of Z, what you're giving is Z equals 1 by 2. So C, that is 3 by 2. Okay, 1 by 2 minus 1, that is 1 by 2. I mean minus 1 by 2 squared, that is 1 by 4. I have 3 by 2 into 4 by 1. So 2 ones are 2 twos are, that is the value of C would be equal to 6. Okay. Now, very important step here. I'll write it as very important step. Okay. So this is for repeated poles or repeated roots. Repeated roots, or I can call it as repeated poles. Okay. So for repeated roots or repeated poles, if I want to find it, I'll be going for this term here. Okay, so let me check here. So this is A. I need to find out plus 1 divided by, that is the value. What you have here, that is entirely wrong. It is entirely wrong. And if you take like Z is equal to 1, it is entirely wrong. So what we have to do in order to find out A, okay, in order to find out A, I have 1 divided by 2 minus 1 factorial. So it is repeated twice. Okay, so that's the reason why I take it as 2. So it is repeated twice. Okay, so the number of times it is repeated, I can write it as number of times it is repeated. Okay, next I have d by dz of this function over here, z plus 1. Okay, z plus 1, I need to differentiate it. Okay, so differentiate it, z plus 1 divided by z minus 1 by 2. Okay, so the value of A, I'll leave this differentiation to you in order to find out what is A. Okay, so the value of A, if you want to find out, it would be quite easy if you perform the differentiation first and then 1 divided by 2 minus 1 factorial. So 2 minus 1 factorial is nothing but 1. 1 factorial is 1, you know that, and the value of A is found to be, okay, So the value of A is found to be, yes, it is minus 6. Okay, so the value of A is found to be minus 6. Okay, value of A is found to be minus 6. Let me show it how did I do. Okay, so A, that is 1 divided by 1 factorial d by dz, isn't it? D by dz of this function, whatever I have written, z plus 1 divided by z minus 1 by 2. Okay, so z minus 1 by 2, the whole squared. Okay, z minus 1 by 2 the whole squared. So what is here? Z minus 1 by 2. Okay, this is z plus 1. This is z plus 1 over here. So if I differentiate it, it's 1 minus z plus 1 into 1 again. Okay, so 1 divided by 1 factorial is 1. So I have z minus 1 by 2 minus z. So this get cancelled, and you have over here, which is minus z minus 1. Okay, minus z minus 1, I'll be having this function here as z minus 1 by 2 the whole square, and this z value over here, which is equal to what it is, which is equal to 1. Okay, so the value of z would be equal to 1 here. So this is minus 1 by 2 minus 1, this is minus 3 by 2. Okay, z minus 1 by 2, that is 1 by 2. Okay, 1 by 2 the whole square, that is minus 3 by 2 into 4 divided by 1. So 2 ones are, this is 2 twos are, and the value of A is said to be minus 6. Okay, so this is how you can differentiate it once. Okay, so though it is repeated twice, you have to differentiate it once, and this one here 1 factorial, it is 2 minus 1. Okay, so that's how we are going to take it. So you have got the value of A to be equal to minus 6 and B to be equal to, what's the value of B? What's the value of B? 4, 6. Okay, 4, 6. Okay, so the value of C is said to be 6. The value of B is said to be 4 here. Okay, so now replacing the constants there. So replacing constants. So how do I get x of z divided by z? That would be equal to z plus 1 divided by z minus 1 the whole squared into z minus 1 by 2. That would be equal to A divided by z minus 1 plus B divided by z minus 1 the whole square plus C divided by z minus 1 by 2. Okay, so the value of A, what's the value of A here? The value of A is said to be minus 6. Minus 6 divided by z minus 1 plus, what's the value of B? Be careful. B is said to be 4 divided by z minus 1 the whole square plus, what's the value of C? The value of C is said to be 6 divided by z minus 1 by 2. Okay, so these are the things after replacing the constants for A, B and C. Okay, so these are the constants what I have there. That would be equal to x of z divided by z. Okay, so in order to find out what is x of z, I need to multiply it by z again. That is minus 6z divided by z minus 1 plus 4z divided by z minus 1 the whole square plus 6z divided by z minus 1 by 2. Okay, so this is x of z. From x of z, I need to find out what is x of n. Okay, so from x of z, I need to take the inverse z transform. IZT refers to inverse z transform. So x of z, that would be equal to, yeah, again to find out, taking inverse z transforms. Inverse z transforms. Inverse z transforms. Okay, so I have mod z greater than 1. That is one thing that you are going to find out. So the pole, whatever the poles that is there, z is equal to 1 by 2, z is equal to 1 here. So this is the first pole, this is the second pole, it is repeated. It is repeated. Okay, so now what you are going to get, x of z, that would be equal to what it is. It would be minus 6 z divided by z minus 1 plus, okay, plus 4 z divided by z minus 1 the whole square plus what it is, you are going to have 6 6 multiplied with z divided by z minus 1 by 2. Okay, so you are going to have inverse z transform. So taking mod z greater than 1. So this is the ROC here. This is mod z greater than 1. If I want to find out x of n, what do I do? Minus 6 into u of n, that is 1 power n u of n. 1 power n is 1 power n is said to be equal to 1 there. Okay, plus 4 into z divided by z minus 1 the whole square. I'll do it as n into u of n plus 6. Okay, half power n u of n. Okay, so I can rewrite it minus 6 plus 4n plus 6 times 1 by 2 power n. So whole thing is to be multiplied with u of n. So this is x of n here. So x of n, that would be equal to minus 6 plus 4n plus 6 times half power n u of n. So this is the inverse z transform of the given function. Inverse z transform. Okay, so this is how you can find out what is the inverse z transform of the given x of z. Okay, so now moving on to the next problem, the second problem. I hope you understood how we can solve it for repetitive roots. In the same way, I have the next problem. Find the inverse z transform. Find the inverse z transform. Find the inverse z transform of x of z, that would be equal to z squared plus z divided by z minus 1 by 2 cube multiplied with z minus 1 by 4. Okay, so this is the given x of z. So you have to find out for ROC mod z greater than 1 by 2. Okay, so mod z greater than 1 by 2. So that's how you are going to find out for mod z greater than 1 by 2. Generally, it would be you have to observe the ROC first. So after observing the ROC, what you have? So you will be having mod z greater than 1 by 2. It is a positive time sequence. Positive time sequence. It is a right-handed sequence. Okay, so it is said to be a right-handed sequence. Okay, so now I have x of z. Okay, x of z divided by z, that would be equal to z plus 1 divided by z minus 1 by 2 cube, that's multiplied again with z minus 1 by 4. Okay, let me erase here. Z minus 1 by 4. Okay, that is again a divided by z minus 1 by 2 plus b divided by z minus 1 by 2 squared plus c divided by z minus 1 by 2 cube plus d divided by z minus 1 by 4. Okay, so that's how I can write this expression in order to resolve. Okay, in order to resolve into partial fractions. In order to resolve into partial fractions. Okay, so I have the power 3 here. Okay, I have the power 3. So what do I need to do? Let me go ahead and see what would be the solution to this x of z here. Okay, so I have repeated roots. So z equals 1 by 2. Okay, it is repeated thrice. Repeated thrice. Okay, and you have one more pole at z is equal to 1 by 2. You have z is equal to 1 by, sorry, z is equal to 1 by 4 and z is equal to 1 by 2. So z is equal to 1 by 2 is repeated thrice and z is equal to 1 by 4 is one of the pole which is there. Okay, so we already know that and the resultant will be a positive time sequence depending on the ROC that has been mentioned, and x of z it should be resolved into the partial fraction method there. Okay, so now it is quite clear for every one of us. So let me go ahead and write it quickly. A times z minus 1 by 4 into z minus 1 by 2 this whole square plus b z minus 1 by 2, that is z minus 1 by 4, plus c z minus 1 divided by 4 here, and plus d z minus 1 by 2 cube. Okay, so you can find out c and d quickly. I think you can find out c. I'll directly write the answer. C would be equal to 6. You know the method. And the d would be equal to minus 80 there. Okay, so by partial fraction method, okay, so the c value would be equal to 6 and d would be equal to minus 80. Okay, now the main thing is to find out a and d here, the constants a and d, if a and b, if I want to find out, sorry. So how would I find out the value of a, okay, and b, a and b? So very clear, the value is repeated twice here. Okay, so the value is repeated twice, and the value z minus 1 by 2 is repeated once. So looking at the power itself, you can come to know that a, if I want to find out, so that would be z plus 1, okay, divided by z minus 1 by 4. You have to differentiate it twice. Okay, you have to differentiate it twice, and again, what you are going to have, if you want to find out a, that would be 1 divided by 3 minus 1 factorial. Okay, so this is the repetitive roots what you have. Okay, so 3 minus 1 factorial. Next, in order to find out b, what you need to do, 1 divided by, it's repeated once, okay, 2 minus 1 factorial. Okay, so what the value it is there, so here and this value, it should be equal, and you have to differentiate it twice. If it is 2 here, okay, you have to differentiate it twice. If it is 3 here, you have to differentiate it thrice, and here it would be 4 minus 1, that is 1 divided by 3 factorial. Okay, in that way you can remember. And d by dz of the same thing. Okay, so z plus 1 divided by z minus 1 by 4. So the value of a you can chalk out, and this is differentiating twice, successive differentiation, and this is differentiating once. So let me write down here, differentiate twice, and this one, which is differentiate once. Okay, so the value of a and b is to be found out quickly. You can do it, and you can write down the value of a. Okay, so you can find out the value of a to be equal to 80, and the value of b is said to be minus 20 there. Okay, so that's how you can find out the value of a and b, which is a 80 and b would be equal to minus 20. So you have to work it out, and you have to find the values of a and b. Okay, so after finding out the values of a and b, I think we can substitute it in x of z by z. X of z by z, that would be equal to a. What's the value of a? That is equal to 80 divided by z minus 1 by 2. Okay, 80 divided by z minus 1 by 2. What is the value of b? The value of b is said to be minus 20 divided by z minus 1 by 2 the whole square, plus what's the value of c? Plus 6 divided by z minus 1 by 2 a cube. Okay, next, what do I have here? Plus d. What's the value of d there? The value of d is said to be minus 80 divided by z minus 1 divided by 4. Okay, so 80 into z divided by z minus 1 by 2 minus 20 into z divided by z minus 1 by 2 squared plus 6 z divided by z minus 1 by 2 a cube minus 80 into z divided by z minus 1 by 4. Okay, so I have 80 1 by 2 power n u of n minus 20. This one, it is quite simple, which is 1 by 2 power n u of n, and it should be multiplied by n, okay, plus 6. So now, how would you do z divided by z minus 1 by 2 cube? What is the cube of it? Can anyone tell me? If you want to find out the cube of it, it would be easy to find out the cube of it. You can have the function, okay, so z divided by z minus 1 by 2 the whole square, okay. So in the same way you are going to have plus 6, so you'll be having n into n minus 1 divided by 2 factorial, okay. So you'll be having 1 by 2 power n minus 1, okay. So you are going to have it over there as u of n minus 1, okay, minus 80 into, okay, 1 by 4 power n u of n. So it is a standard identity that you want to remember. So you are going to have 1 by 2 power n minus 1. Sorry, here you are going to have n minus 1 as the function there, right? So that is the minus thing what you will be having it. So that is n minus 1 there. So n into half power n minus 1 u of n, okay. So now you can take u of n as a common factor, or you can leave it, okay. This is x of n. So after taking the z transform, okay, so this is how you can remember the values of the z transform there. So inverse z transform, if you want to take it, you can have this problem, and this is said to be one of the repetitively asked problems there, okay. So with this note, I would like to end today's session. It is quite important that you practice, and it would be easy for you to understand, okay. Yeah, we'll stop it here on